Hello friends and my dear students, I welcome you all to my channel. This video is part 2 video on the chapter of squares and square roots, where I will discuss about the properties of perfect squares or square numbers, and I will solve some selected problems of the exercise 3b from the textbook of author RS Aggarwal, which is based on the properties of perfect squares. If you have not watched the previous video, that is part 1 video on the chapter of squares and square roots, I highly suggest that you also watch that video to maintain your continuity of the study of the chapter squares and square roots. If you are new to my channel or not yet subscribed, or if you are visiting my channel for the first time, or if you are seeing this video for the first time, I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my quick notes prepared for the topic of this video, that is about the properties of square numbers or perfect squares. So for perfect squares or square numbers are the same thing, and on the right hand side I will do also all kinds of discussion, concept clarification, and then we'll solve some selected problems of the exercise 3b. Let me check if everything is visible or not. I hope you can see my notes on the left hand side. How can you see my notes? Let me check. Okay. So let's start. So I will discuss about, there are many properties of square numbers. I have divided all the properties in the textbook. There are 11 or 12 properties. I have grouped them as A, B, C, D. The related properties I have grouped. Okay. So a number n is never a perfect square, where n is a natural number. I will read out. Okay, so if you, I will provide a link of the PDF of these notes in the description below, so you can check my notes, quick notes from the link. So do not worry of taking screenshot of my notes. I am reading out my notes, and as I am reading, I will discuss the concepts on the right hand side whenever it is necessary. So the properties under group A is a number n, where n is a natural number, is never a perfect square if the number n ends with the digits 2 or 3 or 7 or 8. I have already discussed in this previous video that if a natural number ends with the digits 2, 3 or 7 or 8, then it is never a perfect square. It is never a square number. Okay. The 2. If n ends with odd number of zeros, if a number ends with odd number of zeros, it cannot be a perfect square, because if a number ends with 0, definitely it means that it is the square of a number of another number, so which will also end in 0. Now let's say if I have a number, let's say 120. Now 120. Now if the ending digit, now if the number has odd number of zeros, then it will never be a perfect square. Why? Because if the any number ends with 0, then it is obvious that the number whose square, let's say A is a number. Now I will use some notation of set. It is better that you get used to it. Whenever I say, I do like this, I write like this. If you are already familiar with the concepts of sets, then it's fine. If I say A belongs to natural number, the capital letter N stands for N is why mention is N is the set of, or collection, you can consider a set as a collection of all natural numbers. And when I write A belongs to this symbol is natural numbers. Okay, so when I write A belongs to, this symbol is belongs to, when I write A belongs to n, this means that A is a natural number. Now, so okay, so A is a natural number, and let A B is also a natural number, and let B square is equal to A. So definitely A will be a perfect square, and so and whose square A is? B square. So if B contains, if the number B ends with n zeros, where n is a natural number, where n is also a natural number, if B ends with n zeros, this will imply that A will ends with twice n zeros. So this is a concept, this is a very basic concept you can clearly understand from common sense, that if any number you take 10, see B is 10, it has one 0, so we can see that 10 square is 100, 10 square is 100. So in the 10, 10 was ending with 10 and 100 is ending with 20. So let's say let's say 500 square, 500 square is 250000. Now you can see 500 has 2 squares and 250,000 has 4 squares. So if we have B square equals to A, and if the number B ends with n number of zeros, where n is a natural number, like n could be 1, 2, 3, 4, 5, 6, like that. So if B ends with n zeros, then A, and A is not A, what is A? A is B square, then A will end with twice n zeros. So hence any number which ends with zeros, 10, 20, 30, whatever, this number, this twice of n is always even, whatever be the value of n, where n is a natural number. For n a natural number, 2 into n is always an even number. So if a perfect square ends with 0, then definitely it will have even number of zeros. So that is why it is saying if a number ends with odd number of zeros, it cannot be a perfect square, because if any number ends with 0, then definitely it has to be a square of a number which also ends in 0, and then definitely the perfect square should have even number of zeros. So while I am speaking, you can take notes, because not everything that I will speak, I will write it down. So the major things I am writing down on the right hand side. You can take screenshot of the notes on the right hand side, but also when I am speaking, try to take some notes. Okay. What is point number 3? Dividing n by 3 leaves a remainder 2. If the number n, if you are given a number n, if you divide the number by 3 and it leaves a remainder 2, then it is not a perfect square. Now the reason I do not know. The reason I don't know. I might try to figure it out. Why is this so? But in a later video. Also, for a given number n, if you divide it by 4 and it leaves a remainder either 2 or 3, then also the number is not a perfect square. These two things you have to remember. Any number divided by 3, so given a number, you can quickly check whether it's a perfect square or not. You divide it by 3. If it leaves a remainder 2, it is not a perfect square. And if you divide it by 4, if it leaves a remainder 2 or 3, then it is also not a perfect square. Now it says that dividing n by 3, if it leaves a remainder 2, it is not a perfect square. But what if the number n, when you divide it by 3, it leaves a remainder which is not 2. Let's say it leaves a remainder 1. Will it confirm that the number is not a perfect square? I don't know. Similarly, for point number 4, if you are given a number, if you divide it by 4 and it leaves a remainder, let's say 1, then will it be a perfect square? I don't know. I will have to figure this out later on. Okay. So group B, square of an odd number is an odd number. So if you take the square of an odd number, the square will also be odd. So if you have b square, if we have b square equals to a, where a and b both are natural numbers, where I'm saying a comma b belongs to n, this means that both a and b belongs to n, that is both a and b are natural numbers. If b square equals to a, then odd b will imply odd a. If b is odd, then a will be odd. Also, if b is even, that is even b will imply its square will also be even. So this is the concept. Okay. Now in the notes on the left hand side, you can clearly see I have given a very brief proof of the fact that square of an odd number is also an odd number. Let me discuss it a little bit. So any odd number in the notes, it is written 2n plus 1, but I think it should be 2n minus 1. So any odd number, you can write it in the form 2n minus 1. Odd is 2n minus 1, where n is a natural number, when n is a natural number. So any odd number, any odd natural number you can express in the form of 2n minus 1, where n is a natural number. So if you put n equals to 1, you will get the first odd natural number, which is 1. If you put n equals to 2, you will get the second odd natural number, which is 3. So like this, if you keep on putting n equals to 1, 2, 3, 4, 5, 6, you will get the consecutive odd natural numbers. Now, so any odd number will be in the form 2n minus 1. Now, if you take the square of it, I am trying to see whether any odd number, if I take its square, whether the square will also be an odd number or not. Now, 2n minus square, you must be familiar with this algebraic identity that a minus b whole square is equal to a square minus 2ab. Minus 2ab means 2 multiplied by a multiplied by b plus b square. Also, a plus b whole square is equal to a square plus 2ab plus b square. If I apply the a minus b whole square formula in 2n minus 1 whole square, this will be 2n whole square minus 2 into a, which is 2n, b is 1, and plus b square. So this is equal to 4n square minus 4n plus 1. So this is equal to 4n square minus 4n plus 1. Now this is from 4n square minus 4n, I can take 2 common, and I will get 2n square minus 2n plus 1. Now this thing I can write it as, I can assume that 2n square minus 2n, this will obviously be a natural number. 2n square will always be greater than 2n. So this I can write it as in the form 2k plus 1, where k is equal to 2n square minus 2n. So you can see the 2n minus 1, which was odd number, its square is coming to be in the form of 2k plus 1, where k is also a natural number. Okay, a natural number. So definitely this thing is odd natural number, and we know that any odd natural number can always be expressed as 2n minus 1. Okay, sorry. So here we got 2k plus 1. Also remember that this will 2k plus 1 will also be an odd natural number. So if I said that any odd natural number, in the very beginning I said that every odd natural number, it can be expressed in the form 2n minus 1. But please note that if n is a natural number, n is a natural number, then 2n plus 1 is odd. If n is a natural number, then 2n plus 1 will always be an odd natural number. Hence, we can say that the square of 2n minus 1, that is 2n minus 1 whole square, we got in the form of 2k plus 1, which is an odd natural number. Okay, so this was the fact that square of any odd number, that is odd natural number, is also an odd natural number. Category C is saying, I hope you can see the notes properly. Okay. The category C says that the square of an even number, by number I mean a natural number, is also even. Now you know that any even natural number can be expressed in the form 2n, where n is a natural number. You take any even natural number, 2 can be expressed as 2 into 1, 4, 2 into 2. So any even natural number can be expressed in the form twice of n, where n is a natural number. Now if you take the square, if you take 2n square, this is equal to 4n square. If you take 2 common, I get 2 into 2n square. I can write it in the form 2k, where k is equal to 2n square, and if n is a natural number, then definitely 2n square is also a natural number, and hence this is, we know, is also even natural number. This is also even. I have no idea, my handwriting is not horizontal, it is kind of having an angle with the base, or horizontal, I have no idea. Okay, so we see that the square of an even number is also a even natural number. The square of an even natural number is also a even natural number. So that was property C. Property D. Property D. It says that if a by b is a proper fraction, by proper fraction it means that if a by b is a proper fraction means the numerator is less than the denominator. My machine is giving me a lot of trouble. What is wrong? Anyway, so this implies that is a less than b. Numerator is less than the denominator. A by b is a proper fraction. This implies, as per the property, that the square of a proper fraction is always less than the proper fraction itself. Now, why is it so? Why is it so? Why is it so? Okay, so now the square of a proper fraction is less than the number itself. Okay, so this implies, if this is true, if we assume that this is true, that is a by b whole square, a by b is the proper fraction, a by b whole square is less than a by b, what this will, a by b whole square is a square by b square. We are getting a square by b square is less than a by b. Okay, now if you have this kind of relation between two fractions, if if you have a fraction, this relation inequality that let's say P by Q is a fraction less than R by S, then this imply if you do the cross products, PS, P multiplied by S will be less than Q multiplied by R. This is result. If you have two fractions P by Q and R by S, and it is given that P by Q is less than R by S, then from cross product you will have PS less than QR. Now this implies from here, if you apply the concept from the right hand side, this will have, if you do the cross product, A square multiplied by B is less than B is less than B square multiplied by A. Now this implies I can cancel out 1A from both sides and 1B from both sides. So I get, so this is nothing but A multiplied by B is less than B multiplied by B multiplied by A. If I cancel 1A from both sides and 1B from both sides, what do we get? We get from the left hand side it is remaining A, and from the right hand side it is remaining B, which is true. True since A by B is a proper fraction. So we can clearly see that if A by B, we clearly see that if A is less than B, then we are clearly having A by B whole square less than A by B. And if A is less than B, then A by B, the fraction will be a proper fraction. So this is the very brief explanation of the fact that if A by B is a proper fraction, then the square of A by B will be less than the fraction itself, that is A by B. Okay. Next properties is E, which says that for every natural number n we have, if we consider n is a natural number, any natural number, that is 1 2 3 4 5 6 7 8 like that, counting number, then we have n plus 1 square minus n square. Now what is this? This is the difference of two, basically this is the difference of two consecutive perfect squares. What is n plus 1 whole square? N plus 1 whole square, n plus 1 is square of n plus 1, which is a natural number, because the property is based on the fact that small n is a natural number. If small n is a natural number, then definitely n plus 1 is also a natural number. N plus 1 is a consecutive natural number. So anyway, so n plus 1 is a natural number. Also, n square is square of n, natural number. So n plus 1 are consecutive, are definitely consecutive natural numbers. N and n plus 1 are consecutive natural numbers, definitely. So what is n plus 1 square minus n square? These are the squares of two consecutive natural numbers. Now this is, if I apply the formula of a plus b whole square, I get n plus 1 whole square is equal to n square plus 2 into n into 1 plus 1 square, and I have minus n square. This is equal to n square gets cancelled out. This is 2n plus 1. Now this is nothing but n plus 1 plus 1. So you see the difference of two consecutive perfect squares. The difference of two consecutive perfect squares is equal to the sum of the uh, sorry, if for two consecutive natural numbers n and n plus 1, you will have n plus 1 square minus n square is equal to the sum of the two numbers, that is n plus 1 and n. So the idea is, if you have two consecutive natural numbers n and n plus 1, then the difference of their squares, that is n plus 1 square minus n square, will be the sum of them, that is n plus 1 plus n. So this is the concept. And the second one is that the sum of the sum of first n odd natural numbers is equal to n square. So the sum of first odd natural number is 1, which is equal to 1 square. The sum of first two odd natural number is 1 plus 3, which is 4, which is equal to 2 square. Over here n was 1. We are considering the first one consecutive odd natural numbers. Over here n was 2, that is, we are considering the first two consecutive odd natural numbers. Likewise, if you consider the first three consecutive odd natural numbers, its sum will be 1 plus 3 plus 5, which is equal to 9, which is equal to 3 square. Here n equals to 3. So you see that it is the case that the sum of 3 square, where n was 3. 1 plus 3, we are adding the first two odd natural numbers, first two. So it is 2. So it is, the result is 2 square. So definitely, if you have the sum of first n consecutive odd natural numbers will be 2n minus 1. So 1 plus 3 plus 5 plus 3 plus 5 plus like this, the last term will be 2n minus 1, and this is equal to n square. This is a property. So this is the last one is the sum of first n odd natural numbers, n square. Okay. Now property F is about a Pythagorean triplet. Property F is Pythagorean triplet. Now what is a Pythagorean triplet? Three natural numbers A, B and C are said to form a Pythagorean triplet. A Pythagorean triplet is represented as, if A, B and C are three natural numbers, and if A, B and C form a Pythagorean triplet, the triplet we express as, we write it inside a bracket with comma separated. So A comma B comma C inside the bracket will form a Pythagorean triplet if we have A square plus B square equals to C square. The order is different. Just like, say, 2, no, not 2, let's say 3, 4 and 5, this is a Pythagorean triplet, because we can see that over here this is A, you can consider this is B and this is C. So A square plus B square is equal to 3 square plus 4 square, which is equal to 9 plus 16 is equal to 25, which is equal to 5 square, and you can see this is equal to C square. So 3 comma 4 comma 5 is a Pythagorean triplet. So this is just an idea that any natural numbers, A, B and C has to be a natural numbers. So A comma B comma C will form a Pythagorean triplet if we have A square plus B square equals to C square. Now based on this Pythagorean triplet, an important result is that for any natural number m, m belongs to natural number and uh, m is greater than 1. For any natural number greater than 1, for any natural number m which is greater than 1, you will always have this as a Pythagorean triplet. That is, the first one is 2m, the second is m square minus 1, and the third one is m square plus 1. This Pythagorean triplet, uh, Pythagorean, this is a Pythagorean triplet will always form a Pythagorean triplet where m is greater than 1 and m is a natural number. If you substitute m, any natural number greater than 1, and if you so you can see for m equals to 2, we have 2 into 2 and 2 square minus 1 and 2 square plus 1 is a Pythagorean triplet. In short, I am writing PYT. That is 4 and 3 and 5 is a Pythagorean triplet. You can also see for m equals to 3, you can see 2 into 3 multiplied by 3 square minus 1 and 3 square plus 1 will be is a Pythagorean triplet. This implies that 3 into 6 comma 8 and 10, this is also a Pythagorean triplet. This means that 6 square plus 8 square is equal to 36 plus 64 is equal to 100 is equal to 10 square. So if you have a result that for any natural number m which is greater than 1, the triplet 2m comma m square minus 1 comma m square plus 1 will always be a Pythagorean triplet. Okay. Property G. What is property G saying? Between every two consecutive squares, n square and n plus 1 square, there are 2n number of non-perfect square numbers. Now, between every two consecutive squares, n square and n plus 1 square. So, definitely, what is meant by consecutive squares? So, consecutive squares are like say 1 and 4 are consecutive squares because this is 1 square and 2 square consecutive squares. So 2 not 2 4 and 9 is a consecutive squares because it is 2 square and 3 square. So we can say that n square and n plus 1, these are two consecutive squares where n is a natural number. Now it is saying that between, if you take the value of any value of n, then definitely n square and n plus 1 square will be two consecutive natural numbers. Between these two consecutive natural numbers, it is saying there are 2n number of non-perfect square numbers. Now, first thing is that between, you must understand that between n square and n plus 1 square, there are no perfect squares. That is, any number you consider between the numbers n square and n plus 1 whole square, any numbers in between them, none of them is a perfect square. Why? Why is it so? Because the because n and n plus 1 are consecutive integers. N and n plus 1 are consecutive integers, and n square, which is the square of n. So the next square number after n square has to be n plus 1 square. Has to be n plus 1 square. Just like you say between, let's say, 3 and 6. Between 3 and 6. So 3 square, and let's say we are taking 3 and 6, not 3 and 6, it has to be the consecutive numbers. N and n plus 1 are consecutive numbers. Let's say 3 and 4. So 3 and 4. So 3 square is equal to 9 and 4 square is equal to 16. So between, as you can see, that between 9 and 16, what are the numbers? The numbers are numbers between 9 and 16 is equal to, which are the numbers? 10, 11, 12, like this, up to 15. So 10, 11, 12, 13, 14, 15 are the numbers between 9 and 16. So you can see that none of them is a perfect square. So it is true that between between n square and n plus 1 whole square, that is, these are two consecutive square numbers. Between them there will be no perfect squares. Now second thing is that how many numbers are there. I'm trying to explain why is it the fact that between two consecutive squares, n square and n plus 1 whole square, there are 2n number of non-perfect square numbers. I'm trying to prove this. So how many numbers are there between n square and n plus 1 whole square? The answer is n plus 1 whole square minus n square minus 1. The concept is, always remember that between numbers, by numbers I mean natural numbers, not natural numbers actually, between integers, it is better to say between two integers a and b, where a is less than b, there are b minus a minus 1 integers. A and b are two integers where a less than b. Then between a and b, that is all the numbers which are greater than a and less than b, how many integers are there? It is b minus a minus 1. So this is the concept I am applying here. How many numbers are there between n square and n plus 1 whole square? It will be n plus 1 whole square minus n square minus 1. Now you see n plus 1 whole square minus n square minus 1. What is this number? If I apply the formula of a plus b whole square, I know that n plus 1 whole square will be n square plus twice n plus 1, and I have minus n square minus 1. So 1 cancels, n square cancels. This is coming out to be twice n. Hence the result that between two consecutive squares which are n square and n plus 1 whole square, there are 2n number of non-perfect square numbers. So that was property G. Property H. This is also a very nice property. Property H says that if a and b are two consecutive odd integers or even integers, odd integers, not integers actually, odd and even natural numbers, a and B are consecutive, odd or even. It can be odd or even natural numbers. This will imply that basically, like for example, a, if a is a 1, then b, a is an odd integer, then b has to be the next consecutive odd integer of 1 will be 3. Similarly, if a is 6, then b has to be the next consecutive even integer has to be 8, like this. Okay, so this will imply if a and b are consecutive odd integers, odd natural numbers, or even natural numbers, the product of them a into b will be equal to b minus 1 whole square minus a square. This is the result. Now why is it so? Let me explain. Now as you can see that b is the a and b are two consecutive odd natural numbers or even natural numbers. So I can clearly see that uh, uh, I can clearly see that b will be equal to a plus 2. B will be equal to a plus 2, because you see the difference of them will be 2. You can see that the difference is 1 and 3, the difference is 2. 6 and 8, the difference 2. The difference of any two consecutive odd or even natural numbers is always 2. Okay. Now let's see why a multiplied by b is coming to be b minus 1 whole square and minus a square. Okay. So I can see that b will be equals to a plus 2. Now also you see that there is between any two consecutive odd or even natural numbers, there exists one integer between them. So let's say, so as you can see, between a and b, if a equals to 1 and b equals to 3, between a and b I can see another integer which is 2. So between 6 and 8 there is an integer 7. So let's say that integer be c. A and B are consecutive odd or even integers. Irrespective of whether they are odd natural numbers, a and b are odd natural numbers, odd or even natural numbers, there will be an integer or there will be a natural number between a and b, only one natural number, let that be c. And I can clearly see that a, now ACB will be consecutive natural numbers. Please try to understand this fact that A and B are consecutive, either odd or even natural numbers. Whether, irrespective of the fact that whether A and B are odd natural numbers or even natural numbers, between A and B there will be exactly one natural number. Let that number be C, and we will see that we can clearly see that A will be equal to C minus 1 and ACB will be three consecutive natural numbers. We can say that A equals to C minus 1 and B equals to C plus 1. A equals to wait a second, B minus 1 whole square. No, I think I've written a little wrong in the notes. I'm so sorry. So no, I will rub this thing. Let me see. So I have this. If A and B are two consecutive or even natural numbers, I will have exactly one natural number between A and B. If I call it that C, then ACB will be definitely three consecutive natural numbers. Three consecutive natural numbers. And then I can say that A equals to C minus 1 and B will be C plus 1. So this implies, okay. So this implies A multiplied by B will equal to C minus 1 multiplied by C plus 1. Now this is equal to uh, C square minus 1. Why? There is a algebraic identity, or you can say, yes, algebraic identity, that for any two numbers A and B, you will have A plus B multiplied by A minus B is equal to A square minus B square. You have this algebraic identity. So this identity and A plus B whole square and A minus B whole square I have written down in a separate properties, which is I of the square numbers, perfect squares. So now, we can see that A multiplied by B will be equal to C square minus 1. Now what is C? C is the natural number between A and B. There will be only exactly one natural number between A and B, where A and B are two consecutive or even natural numbers. So you can compute the value of product of two consecutive odd or even natural numbers with the formula C square minus 1. What is C? C is the number, the natural number between A and B. Okay, so and the properties I are those algebraic formulas that I have already mentioned. A plus B whole square equals to A square plus 2AB plus B square. A minus B whole square equals to A square minus 2AB plus B square. And A plus B into A minus B equals to A square minus B square. Now let's try to solve some selected problems from the exercise 3B. Let me see if you can see the problems of exercise 3B. Okay, you can see it now. Okay, so let's now try to solve selected problems. I will not solve all of them. For a particular problem number, I will solve few of them so that you will get the idea of how to solve the remaining problems. Exercise 3B. The first one is give reason to show that none of the numbers given below is a perfect square. Okay. Let's try a few of them. The first one is 5, 3, 7, 0. Reason is not a perfect square. Reason. I'm writing R colon. R means reason that ends with, we know any number that ends with the digits 2, 3, 2 or 3 or 7 or 8 cannot be a perfect square. So ends with digit 2. So this is the reason that 5, 3, 7, 2 cannot be a perfect square. Okay. So 5, 3, 7, 2. Similarly, 5, 9, 6, 3. Oh no, sorry. So 5, 3, 7, 2 cannot be a perfect square because it ends with the digit 2. Similarly, 5, 9, I'm not writing it. I'm saying 5, 9, 6, 3 cannot be a perfect square because it is ending with the digit 3, and we know that any number that ends, R stands for reason, any number that ends with the digit 2 or 3 or 7 or 8 cannot be a perfect square. Okay, so 3, I'm not doing 3, 8, 4, 5, 7, it is ending with the digit 7, so it is not a perfect square. 5, 3, 6, 0, reason ends with odd number of zeros. Any number that ends with odd number of zeros cannot be a perfect square. Any number, if it ends with 0 and if it is a perfect square, then it has to end with even number of zeros. Okay. So problem part 6 is also same, 64000. It is ending with 3 zeros, which is odd. 3 is odd. And similarly 7, part 7, it is ending with 5 zeros. So odd number of zeros. Okay, let's do problem number 2. Which of the following are squares of even numbers? Which of the following are squares of even numbers? Okay, so we can clearly say, is 196 squares of even numbers? Yes, because reason is that ends with, not ends actually, the reason is it is given that by these square numbers, it is given that all these numbers which are square numbers. Now it is asking which of the following are squares of even numbers. The reason is 196 is even. So if it is even, if 196 is even and it is a perfect square, then the number whose square is 196, that also has to be even number. Okay. 4, part 2, 441. No, this is not, 441 is not a square of even numbers. No. Reason is 441 itself is odd. If it is a square and if it is odd, then the number whose square is 441, that number also has to be an odd number. Okay. So rest I think you can do. 900, 625. 900 will be a 900. Yes, because reason is 900 is even. 625, no, because 625 is odd. So the number whose square is 625, that number also has to be odd. 324, it is true. 324 is an even number, so it will be square of an even number. Okay, let's do problem number 3, and I hope the fonts are now coming very smaller. Let me check whether it's visible or not. No, not really that visible. Let me zoom in a bit. Okay, so question number 3 is, which of the following are squares of odd numbers? Okay, so this time, no. So I think I need not do, okay, the logic is same. 484, is it 484, is this number a square of an odd number? Definitely not. Why? Because 484 number is even. That is, it will be the square of a number with that number also will be even. Part 2 is 961. Yes, this will be a square of an odd number. Reason, 961 itself is odd. So I think you can do the rest of the parts. Okay, let's do problem number 4. Problem number 4. Part 1 says that find, without adding, find the sum. So it is adding consecutive odd integers 1, 3, 5, 7, 9, 11 and 13. So how many odd consecutive natural numbers are here? 1, 2, 3, 4, 5, 6, 7. 7 consecutive, these are 7 consecutive odd natural numbers. So by the property we know that the sum of first n odd natural numbers is equal to n square will be equal to 7 square, that is 49. Okay. Similarly, I hope I did not do the rest of the parts. Let's see what is. So this time we are having. So this time part 2 is 1 plus 3 plus 5 plus 7, like this. It has addition up to 19. So how many consecutive odd natural numbers are here? So up to 13 we got there are seven consecutive odd natural numbers. So after 13 there will be 15, 16, 15, 17 and 19, three more. So we are having here 10 consecutive odd natural numbers. So this is the sum will be equal to 10 square, which is equal to 100. Now similarly, part 3 it is sum of 1 plus 3 plus 5 plus 7, like this. It is up to 23. So up to 19 there were 10 odd natural numbers. So after 19 it will be 21 and 23. So two more are added. So this is equal to, we have here 12 consecutive, or rather it should these are actually first 12 odd natural numbers. These are first 12 odd natural numbers. So by the property, their sum will be equal to 12 square. This is equal to 144. Okay. Let's do problem number 5. What is problem number 5, part 1? Express 81 as the sum of 9 odd numbers. Okay, express 81. Okay, so we know that 81 is equal to 9 square. So definitely we know that the sum of first n odd natural numbers is equal to n square. So this will be equal to sum of first first 9 odd natural numbers. So this is equal to 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is how we express 81 as the sum of first 9 odd natural numbers. Okay. Part 2 is express 100 as the sum of 10 odd numbers. So definitely we know 100 is equal to 10 square. So equal to sum of first 10 odd numbers. Numbers means natural numbers. So definitely this will be equal to, so the first 9 odd natural numbers was 1 to 17. So this will be 1 plus 3 plus 5 plus 7 plus up to we have up to 19. Okay, let's do problem number 6. Write a Pythagorean triplet whose smallest number is okay. Now, in a Pythagorean triplet, remember that we know that for all natural number m, for m belongs to natural number and m is greater than 1, we have 2m, comma m square minus 1 and m square plus 1 will be a Pythagorean triplet. Now, in these three numbers, that is 2m, comma 2m and m square minus 1 and m square plus 1, the smallest is this 2m. This is the smallest. So, if the question is write a Pythagorean triplet whose smallest number is 6. So, we must have let what so for the if so we have to find m such that 2m is equal to 6. So, 2m equal to 6 implies m equals to 3. This implies the Pythagorean triplet, which I am in short writing P by T, is equal to 2 is equal to 2 into 3, 2m, 3 square minus 1 and 3 square plus 1. This is equal to 6, 3 square, 9 minus 1, 8 and 10. Okay. Part 2, it is given the smallest is 14. So, we must have twice m equals to 14. So, this implies m is equal to 7. M is equal to 7. So, this implies P by T, that is Pythagorean triplet, will be equal to 2 multiplied by 7, 7 square minus 1 and 7 square plus 1. So, this is equal to 14. 49 minus 1 is 48 and 49 plus 1 is 50. Okay. Part 3 is 16. So, let us say 2m equals to 16. This implies m equals to 8. This implies the Pythagorean triplet will be equal to twice of m, that is 2 into 8 minus m square minus 1, that is 8 square minus 1 and 8 square plus 1. This is equal to 16, 64, 8 square is 64, 64 minus 1 is 63 and 64 plus 1 is 65. Okay. So, while I am solving the problems, you can pause the video. You should pause the video and take a screenshot of my solution if you think this will be beneficial to you in the future. So, that was problem 6. Let's do problem number 7. Okay. Problem number 7, I see you cannot see it properly. Now you can see. Okay. Problem number 7 is evaluate. We have to evaluate. The first one is 38 square minus 37 square. Evaluate. 38 square minus 37 square. Now you can clearly see that this is equal to 37 plus 38 is 37 plus 1 square minus 37 square. So, this is of the form n plus 1 square minus n square. This is equal to this is equal to n plus 1 plus n, that is n plus 1 plus n, n plus 1 plus n. Now, basically you have to consider, you have to just express 38 as 37 plus 1. So, this is 37 plus 1 whole square minus 37 square. This will be 37 plus 1 plus 37. This is equal to 37 plus 37 is this is basically, actually this is nothing but 2n plus 1, 2n plus 1. But remember that this is n. In this problem, example, n is 37. So this is 2 into 37 plus 1. This is equal to 74 plus 1. This is equal to 75. Okay, part 2. It is 75 square minus 74 square. This is equal to 74 plus 1 square minus 74 square. So this is equal to actually 2 into 74 plus 1. This is equal to 148 plus 1. This is 149. Now I hope you can do the part 4 and part 5 of the problem number 7. So it is similarly, I hope you got the concept, the idea how to solve this problem. So I am not doing part 4 and part 5. Also there is part 3. They are all same. They are all same. Okay. Let's move on to question number 8. So remember that n plus 1 whole square minus n square is 2n plus 1. In the textbook it is written as n plus 1 plus n, which is essentially 2n plus 1. Let's do problem number 8. Using the formula a plus b whole square equals to a square plus 2ab plus b square, evaluate. Now this is just it's a time consuming computation. You just have to evaluate using the formula, but you have to wisely express 310 as a plus b. Now I can write it as a plus b. So it's better. How will you write 310 as a sum of two numbers a and b, so that it will be convenient and easy to find, to compute a square plus a square, b square and ab. So you know the formula is that a plus b whole square, a plus b whole square is equal to a square plus 2ab plus b square. If you are given a plus b, you have to express a plus b as, if you are given the value of a plus b, from that you have to find what you have to choose a and b, such that the computation of a square and b square will be easier, relatively easier. Now for 310, I think this will be a good choice, that is 300 plus 10, because 300 square and 10 square will be easy to compute. So this is 300 square plus 2 into 300 multiplied by 10 plus 10 square. Now 300 square is 9 and 4 zeros. Now 2 into 300 into 10 is 6000, and we have 100. So this is equal to 96100. This is the value. Okay. Now please do not try to express 3110 as, let's say 3, let's say 1 minus 1. You can do this. 1 is fine, but to find the square of 311, it will take some time. So please do not do this. This is a bad idea. So you have to wisely express the given number in terms of summation, sum of two numbers, so that is a and b, such that a square and b square, it is easy to compute a square and b square. Let's do another one. Let's say okay, there is part 2, 508 square. Now how will you express 508 as a plus b? Now one choice is, you can go with 500 plus 8. This is a good choice. This is a good choice. Always try to express the given number as, always try to see whether you can have some, for a and b, you can have any of them with a ending zeros. Ending zeros. Now, so this is what? 500 square plus 2 into 500 multiplied by 8, and we have 8 square. Now this is equal to 250000. 500 square, 500 ends with 2 zeros, and so definitely square will end with 4 zeros, and we have 5 square is 25. Now what is 2 into 500 into 8? 2 into 500 is 1000, so 1000 into 8 is 8000, and we have 64. So this is equal to now 2, 5, 8, 0, 64. You have to do the final addition of the numbers, big numbers, carefully. Okay, let's do problem number 9. Problem number 9. Okay, how many questions are there? 13. Problem number 9. Using the formula a minus b whole square. Now we have to use the formula a minus b. Okay, so it is all about wisely choosing a and b from the given number. So part 1, the given number is 196. We have to find 196 whole square, and we have to first express 196 as a minus b by choosing wisely a and b. Now 196, always try to see if you can choose either a or b or both that ends with zeros. Now 196, the closest number that will end with 0 is 200. 200, and I know 200 minus 4 is 196. Now please do not say that please do not express 196 as 100 plus 96. This is a really bogus choice. No. 100 is fine, but squaring of 96 is difficult. Not difficult, I mean it will be time consuming. So this I know, 200 minus 4 whole square, it is of the form a minus b square. So the formula is already given, and you must remember this is a square minus 2ab plus b square. A is a in this problem, a is 200. After expressing 196 as 200 minus 4, a is 200 and b is 4. So this is equal to 4 and 4 zeros, minus 2 into 200 into 4 is 1600, and I have 16. Now the subtraction will be a bit time consuming. Now what is this? So you have to find this 0016. This is 00485. Sorry, 3 00483. Okay, so this is 38400 plus 16. This is equal to 38416. This is the answer. Okay, let's do part 2, which is 689 whole square. Always try to see that we have to express 689 in the form a minus b, where either a or b or both can have ends in zeros. Now 689. Now the nearest number to 689 which will end with 0 is 700. Now we have to do 700. That ends with 0 is not actually 700, but it is 690. 690 also ends with 0. Now you can express it as 690 minus 1. Since it has asked to evaluate the values using the formula a minus b whole square, so definitely we have to express 689 as in the form of a minus b. Now this is a better choice, or 700 minus 19 is a better choice. 700 minus 19 is also 689. So 700, we have 700 is fine, but 19 square we have to compute. But and on the this side, the first one, 690 minus 1, we have to find the squaring of 669. What else can we do? Uh, hmm, Well, I think in both ways, in both the cases, we have to do a little bit of computation. No one is better. Is there any other choice we can think of? Uh, I will go with this one. So this is equal to 690 square minus 2 into 690 multiplied by 1 plus I have 1 square. So this is equal to, we have to find 69 square. 69 into 69 is 81, and 54, 62, and 54, and 36, 41. I don't know whether I am doing the calculation right or wrong. If I am doing any silly mistakes, please do let me know. So 4, I am not really focusing in the calculation mistakes. So this is 4761, and 4761 is 69 into multiplied by 69, but we have 690, so there will be end 2 zeros at the end. So minus 2 into 690, this is 0, 18, and 1 3, and I have plus 1. So now I have to find what is 476100 minus 1380. I have to find this. This is 0, 2, 0, 2, 7, 4, 7, 4. Okay, so this is 474, 720, and plus 1. This is equal to 47471. This is the answer. My answer could be wrong. I'm not really focusing on any kind of calculation mistake. If you see any calculation mistake, you can please let me know in the comment section. Okay, that was question number 9. What is question number 10? Okay, question number 10 is evaluate. Evaluate part 1. We can see it is a product of two numbers. And what are the numbers? 69 multiplied by 71. We can clearly see that 69 is an odd number, and the 71 is its consecutive odd number to 69. So we know that from the concept that A multiplied by B will be equal to C square minus 1 square, where A, C, B are consecutive natural numbers, Okay, so what in this case, what will be C? So in this case, A is equal to 69, B is equal to 71. So this implies C will be equal to A plus 1, that is equal to 70. So 69 multiplied by 71 will be equal to C square minus 1, that is 70 square minus 1, that is 4900 minus 1. This is equal to 9, 4, and 8, 9. So 4899. Evaluate. Okay, let's do part 2. We have to find 94 multiplied by 106. We can see, okay, now 94 and 106, these are two, no, they are not consecutive, even integers. What to do? 90, 94 into 106. Uh, 94, 96, 98. Evaluate. 88, 92. 94 into 106. So we know that if A and B are any two consecutive odd or even natural numbers, then we can we were able to find A multiplied by B was equal to C square minus 1 square, where C was the natural number, only the natural number between A and B. If A and B are two consecutive odd and even natural numbers, then between A and B there has to be one natural number. That is, if that is C, if we were considering if that was C, then A into B is equal to C square minus A square. Now from this expression 94 into 106, we have to do a similar kind of logic. The logic will be same, but in this case C will not be, as you can see, C will not be the only integer between 94 and 106. So what is, we have to find some integer between 94 and 106, so that uh, so that so that if you consider this is A and this is B, the idea is find C such that C will be a number integer between A and B such that C minus A, midway between A and B, that is C minus A will be equal to C minus A will be equal to B minus C. So find a C which is just midway between A and B. That is, we have C minus A equals to B minus C. Now from this implies that 2C is equal to A plus B. This implies C is equal to A plus B by 2. If we consider a number C between A and B, which is A plus B by 2, which in this case will be 94 plus 106 divided by 2, which is equal to 94 plus 106 is how much? 200 by 2, which is equal to 100. So if we consider C as 100, then I can say A into B will be equal to what is A? A is from C, we have to express A in terms of C and also B in terms of C. So A is nothing but C minus what is C? C is 100. C is 100. So this implies the difference C how can I write A in terms of C? So this implies that A plus 6 is equal to C. From this problem we can see, or we can see that A is equal to C minus 6. So we can write this multiplied by C plus 6. How come 6 we are getting? How come we are getting 6? You can see how come we are getting 6 in this problem. That A, we are writing A as 6 C minus 6, where C is we have found to be 100. So A is C minus 6 and B is C plus 6. So how come we are getting 6? The 6 is coming from the fact that you will see B minus A, B minus A is equal to 106 minus 94, which is equal to 12, which is equal to 12. So B minus A by 2 is equal to 12 by 2 equals to 6. So this is where we are getting C. So now this is equal to C square minus 36. Sorry, C square minus C 6 square. So the idea was to express A into B as in the form of C minus some value and multiplied by C plus that same value. And that same value, which in this problem is 6. 6 is nothing but B minus A by 2. B minus A by 2. And what is C? C is A plus B by 2. A plus B by 2. So, okay. So now this is equal to C is 100 square, 6 square. So this is equal to 10000 minus 36. This is equal to how much is 10000 36. So this is 4. This is 4 6 9 9. So this is 9964 is the answer. So what concept did we apply when we are given the product of these two numbers, this kind of numbers? So A is something and B is something, and you can clearly see that both A and B are even. We have to find C, that will be just in between A and B, midway between A and B, and C will be equals to A plus B by 2. C will be equal to A plus B by 2. Now again you have to find this 6, that is I am expressing A as 6 C minus 6 and B as C plus 6. How come 6 is coming? Where is 6 coming from? 6 is B minus A by 2. B minus A by 2. So you got 6. Then the result will be C minus 6 multiplied by C plus 6. This is C square minus 6 square. And 6 was coming from B minus A by 2. So we have 100 square minus 6 square, which is 9964. Okay. Let's do problem number 11. Problem number 11 is part 1. Evaluate 88 multiplied by 92. Let's see if we can apply the same thing, the same concept as we applied for the part 2 of problem number 10. So 88 and 92. So this is A and this is B. So let's say C will be equal to A plus B by 2. That is equal to 88 plus 92 by 2. This is equal to 10, 18, 180 by 2. That is equal to 90. So C is 90. Also, we need to find B minus A by 2. That is equal to 92 minus 88 divided by 2. This is equal to 4 by 2. This is equal to 2. So A into B will be equal to C minus 2 multiplied by C plus 2. This is equal to, you can check that C is, we have found out to be 90. 90 minus 2 is 88 and 90 plus 2 is 22. So this is nothing but C square minus 2 square. This is nothing but C we have found to be 90. So 90 square minus 2 square. So this is equal to 8100 minus 4. This is equal to 8 890 what this is 80996. 8096. Okay, I hope you got the idea how we are doing the product. So let's do part 2. 78 multiplied by 82. It is the same thing. Consider this as A, consider this as B. Now find C equals to A plus B by 2. That is equal to 78 plus 92 divided by 2. That is equal to 10 and 170 by 2. This is equal to 85. 85. Oh God. 85. 6. 2. 14. 7. Now, wait a second. 80. I think I did something wrong. A plus B by 2 is, oh sorry, this is not 92, this is 82. So this is 82 and this is 160 by 2, this is 80. So C is 80, and also you can find B minus A by 2. B minus A by 2 is equal to 82 minus 78 by 2. This is equal to 4 by 2 equals to 2. So now A into B will be equal to C minus 2 multiplied by C plus 2. That is equal to C square minus 2 square, and 2 was B minus A by 2 was 2. So this is equal to C is what? C is 80. So 80 square minus 2 square. This is equal to 6400 minus 4. So this is equal to 6396. Okay. Let's do problem number 12. Fill in the blanks. Okay, fill in the blanks. The square of an even number is even number. Definitely, from the properties of square numbers or perfect squares, we have seen that the square of an even number is also an even number. Even number. 2. The square of an odd number is odd number. Is odd number. 3. The square of a proper fraction is dash than the given fraction, is smaller or less. We always have A by B, where A by B is a proper fraction, its square is always less than A by B. So the square of a proper fraction is smaller than the given fraction. 4. N square is equal to it is given that n square is equal to the sum of first n dash natural numbers. It will be odd. The sum of first n odd natural numbers. Okay. Problem number 13. These are true and false. These are true and false. Part 1. Can you see the? Oh, you cannot see. Okay. Let me. I hope now you will be able to see. Okay. So, true and false. Part 1 is the number of digits in a perfect square is even. The number of digits in a perfect square is even. No. No. False. I will write false, and below it I will as a reason that 4 is a perfect square and number of digits is 1, which is odd. I'm just writing 4 is a perfect square and the number of digits in 4 is 1, which is odd. So it is saying that the number of digits in a perfect square is even. It is not true. As an example, you can consider 4 or 9. Okay. Part 2. The square of a prime number is prime. The square of a prime number is prime. No, false. False, yes, false. Why? Why? Let's say, let A be prime. Let A be a prime number. It is saying that the square of a prime number. Okay, so let A be a prime. A be prime. This implies A square, the square of A is A square, that is A into A is not prime. Why? Why A square is not prime? Because what is a prime number? A is a prime number because it is only divisible by 1 and the number itself, that is A. But A square, the number A square is divisible by, it is of course divisible by A square and 1, but it is also divisible by A, which need not be 1. For example, 3. Example, let's say 3. 3 is prime. We know that 3 is prime. 3 square equals to 9 is not prime. We know this. 9 is not a prime number. So definitely, why? Because 9 has a factor 3. So we can clearly see that a square of a prime number is not a prime always. Prime not a prime. So this is false. Part 3. The sum of two perfect squares is a perfect square. The sum of two perfect square is a perfect square. I do not think this is correct. This is false. Reason I'm giving as an example. Let's say 2 square plus 3 square is equal to 4 plus 9 equal to 13, not a perfect square. 13 is not a perfect square. So I proved it that the statement is false by giving an example, contradictory example. 2 square is a perfect 4 and 9, they are perfect squares. So 4 plus 9, 13 is not a perfect square. So this statement is false. Part 4. The difference of two perfect square is a perfect square. This is also false, I guess. Because reason is that, let's say 9 minus 4. This is equal to the difference of two perfect squares, that is 3 squares. 9 is equal to 5. 9 is a perfect square. 4 is a perfect square, but the difference 5 is not a perfect square. So this was also it is true, the statement is true, it was proved by giving contradictory example. 5. The product of two perfect squares is a perfect square. The product of two perfect square is a perfect square. Okay, this is a nice one. So let's say this is true. Of course, this is true. Why? Because let's say let A equals to B square, B first perfect square. Let A is a perfect square, and if it is a perfect square, it has to be square of some number, and let that number be B. So let's say we are having A equals to B square. So let A be the first perfect square, and let's say C is equal to D square, P second perfect square. Second perfect square. So C is another perfect square. Let's say C be equal to D square. This implies now we have to check whether A into C is a perfect square or not. A multiplied product of A into C will be equal to B square multiplied by T square. We know from the laws of exponents that this is equal to B into D square. This is definitely a perfect square. Perfect square. So this statement is true. So this brings to an end of solving the problems of 3B based on the properties of perfect squares. This was a very long video, as I have solved quite a bit of problems, most of the problems from exercise 3B. So I hope this video was beneficial to you. If it is, then please like it, share it with your friends, and please once again support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video, the next video will be on the next topic, which let me quickly check what are the next topic. The next topics are shortcut methods for squaring a number. We have to find how to square a number using shortcut method and diagonal method. What else is there? And we have to find the square roots of a perfect square by prime factorization method. What else? Square root of a perfect square by long division method. And what else is left? Square roots of numbers in decimal form. Okay, and that I guess is the last topic. Yes, so 2 or 3 more topics are left, which I will cover in the next 2 or 3 videos. So please stay tuned for the next videos on the chapter of square roots, squares and square roots. So thanks for watching, and until the next video, take care and bye.